So 31, if for 31 I have 2 sine theta plus 1 times 2 cosine theta plus 3 equals 0, I have two different things to solve. Well, since I have two things equal to 0, either that is 0 or this is 0. And notice what happens. Here, you get that the cosine of theta is equal to negative 1.5, which has no solution, because that never happens, because the biggest in size that cosine ever gets is 1 and negative 1. So there's no solution. Over here, you get negative 1/2 is what you get for sine. So then you draw your picture and you ask, so where is sine equal to a negative 1/2? And you get either this point or that point. It's equal to negative 1/2. You got this or this. So what does that mean? That means that there's some point up here where y is equal to 1/2, where sine is equal to 1/2. So I ask myself, where's sine equal to 1/2? And that should be pi over 6. So this down here is going to be 7 pi over 6. And this is going to be 11 pi over 6. So that means we either get one of these two dots. So either theta is equal to 7 pi over 6 plus a number of wasted revolutions, or it could have been 11 pi over 6. It's 2 pi in, yeah? Okay, so it's 31. And so let's look at 33. So it wants to know where is cosine of x plus 1 equal to 2 sine squared of x. Well, since sine squared is 1 minus cosine squared, something I need to have memorized, well, then I can distribute and get 2 minus 2 cosine squared x is equal to this. Well, then I get everything on one side. So I have 2 cosine squared x. And if I subtract 2, I'd get minus 1 on the left. And now here's something set equal to 0. And it should be pretty clear that this thing can factor. So I know that the first two have to multiply together to get the first. So I get a 2 cosine and a cosine. The last two must multiply together to get the last. And so I get a 1 and a negative 1. And I think I need that one to positive and that one to be negative for everything to work out right. Double check. So either that is equal to 0 or this is equal to 0. So I get that the cosine of x is 1/2, or the cosine of x is equal to negative 1. Let me find all the points that do that. Draw my picture and say, where is x equal to a positive 1/2? Well, it is either here or here. So where all those are those places, cosine's on top. So I guess that's pi over 3. And then this is 6 pi over 3. So if I back up 1, I get 5 pi over 3. So either I get pi over 3 plus 2 pi in, which would be one of my answers, or my other family of solutions is going to be 5 pi over 3 plus 2 pi in. Now I need to know where is x equal to negative 1. X is equal to negative 1. Bloop, bloop, over here. And so that means that the x that I'm looking for this time is going to be pi plus any 2 pi in. So there's my 3 families of solutions. Okay. So that's 33. After that, I have 37. So 37 wants to know, where is 37? Where's the cosine of natural log of x equal to 0? Well, I'm just going to let u be equal to ln x. So I just want to know, where's the cosine of u equal to 0? So then if I did that, by making that replacement, it makes it easier to see that cosine is x. So x is going to be equal to 0 here and here. So either my input was equal to pi over 2, or my input was equal to 3 pi over 2 plus any sort of, it's going to be one of those two, right? So plus a 2 pi n plus 2 pi n. But then do you see that if you add just a pi, you get to that one and add just a pi? So I could combine those, say that u is equal to pi over 2 plus pi n. So remember, I can substitute back. That means that natural log of x was equal to pi over 2 plus pi n. But this is log base e of x is equal to pi over 2 plus pi n. Pi over 2 plus pi n. And so that means that e to the this is equal to that. So e to the pi over 2 plus pi n is what my x is equal to. And I'm done. Excuse me, a lot of changing the form. So looking at 45. So when I have 45, it wants to know, where's the tan squared of x sine equal to sine? We'll put a big old caution. Do not divide by a function. Put really small, unless absolutely necessary. Because you do not want to divide by something that could be equal to 0. We know that we like to solve by hand, to solve equations by hand, set equal to 0, and factor. That was the biggest thing that we got out of this. So no matter the equation, trig or any equation, setting equal to 0 and factoring can oftentimes help you from making a silly mistake. So here it's tan squared x sine x minus sine x equals 0. Well, then I can factor out a sine x to get tan squared x minus 1. But tan squared x minus 1, so then that's telling you that either sine of x equals 0 or tan squared x equals 1. So where is sine equal to 0? I guess that's here, right? So this is telling you that x is equal to 0 or pi. If we just want our answers between 0 and 2 pi, so here it wants the answers from 0 to 2 pi. So solve inside of 0 to 2 pi only. So I guess that 0 and pi are going to be two answers. 0 pi. But then when I come over here and I take the square root of both sides, I get that the tangent of x is either plus or minus 1. So tangent is equal to 1 here at pi over 4 and 5 pi over 4, because this is a 4 pi over 4, so if you add 1, that's that. But then it's equal to a negative 1 here at 3 pi over 4 and 1 less than 8 pi over 4, which would be 7 pi over 4. So it's going to be at all of these dots. This one, this one, this one, and this one. So that means we're going to add the points. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So now these odd multiples of pi over 4. So those are going to be all of our answers. So if that's 45, then I need 51. Bloop, 51. So if I'm looking at 51, and I have 2 sine squared u plus sine u minus 6 equals 0. Well, I'm going to try and factor that trinomial into two binomials, where I know that the first two multiply together to get the first, and the last two multiply together to get the last. So I think I'm going to have this and this. And then at the end, I think I'm going to have a 3 and a 2, where this is positive, and wait, where this is negative, and this is positive. So that's going to give me 4 sine minus 3 sine, gives me what I want. And then this gives me the last term I want. Okay, so that means that either 2 sine of u minus 3 equals 0, or sine of u plus 2 equals 0. So either the sine of u is equal to negative 2, which has no solutions, because the most negative sign ever is negative 1. And then this is saying that the sine of u is equal to 3/2. That also has no solutions, because the largest positive that sine ever is 1. So this thing has no answers. So that's 51. Let's look at 53, and we're almost done. So 53. If I'm looking at 53, I have the cosine of alpha plus the sine of alpha is equal to 1. So when is it that the cosine plus the sine is ever equal to 1? Well, we know that we need to change the form. And from experience, we know if we can square both sides, because I don't know anything about sine and cosine, but I do know something about sine squared and cosine squared. Well, I get 1 minus 2 sine squared. Oh, I'm sorry, 1 minus 2 sine alpha plus sine squared. And over here, I get cosine squared. The cosine squared is just 1 minus sine squared, because that's an identity that I have memorized. So if I get everything over to the right-hand side, I'm going to have 2 sine squared alpha, because I take care of that one and that one. And then the 1's are going to cancel out. And then I'm going to have left minus 2 sine squared alpha. So then we remember that we like to set everything equal to 0 and then factor. When you factor, you're going to have sine minus 1 left. So all that's equal to 0. So either 2 sine alpha is equal to 0 or sine alpha minus 1 is equal to 0, which means either sine is 1 or sine is 0. So we're solving this in 0 to 2 pi only. So when I do that, where is sine or my y-coordinate equal to 0? It's 0 here and here, right? And then where's sine equal to 1? It's equal to 1 just up here if alpha was equal to pi over 2. But then we have to be careful. Caution, squaring creates extraneous solutions. So extra or extraneous solutions. And it turns out if you try and plug them back into the original, pi is extraneous. It's extra. It is not a solution to the original equation. It was created when we squared. So there you go. So it's a solution to the squared thing, but it's not a solution to the original one. Okay? All right. So that's 53. The last one we want is 71. So 71. When you are looking at 71, let's see. So let me see what that problem is telling us in 71. Sorry, I'm looking at the wrong section. Excuse me, I was already prepping for tomorrow. So if I look at 71, it tells me that the intensity of light in calories per centimeter squared, yep, is equal to Im sine cubed pi t over d, where Im is the maximum intensity. So it's a maximum intensity. D is, on a clear day with d hours of light, number of hours of light per day. T equals 0 is sunrise, and T is time in hours. T is time in hours. Let me take this and move this back. T is time in hours. So it tells us that if D is equal to 12, if D is equal to 12, solve for T to find when the intensity is equal to half its most intense. So that means we have got 12 hours of sunlight in our day. I want to know when do I multiply that from max intensity and get half max intensity. Well, notice these cancel out. So I get 1/2 is equal to sine cubed pi t over 12, right? So if I then take the cube root of both sides, I get the cube root of 1/2 is equal to sine pi t over 12. Well, then if I take arc sine of both sides, I get the arc sine of the cube root of 1/2 is equal to pi t over 12. Well, that's going to end up giving me 0.9169. Yes. But notice I'm wanting to know when is sine positive. So the calculator gives me an answer in this quadrant. It's always going to give you the reference angle. So arc sine or arc cosine or arc tangent are always going to give you the reference angle. But remember, when we come over here, we could get another time when our y or our sine is equal to the cube root of 1/2. It's going to be both these times. So one of these points is 0.9169, and this right here is going to be pi subtract 0.9169. So that's going to be approximately equal to 2.2247. So that means you have two things. You either have 0.9169 is approximately equal to our pi t over 12, and 2.2247 is approximately equal to our pi t over 12. And then solving for t, you get that t is approximately 8.5 hours, and the other time is t is approximately 3.5 hours. Cool. Awesome. Have a great one, and I'll see you next time.